Okay, hopefully this will wrap it up. I do want to do one of these conceptual problems. And again, you can email me if you have any questions on the ones that I skipped. But look at number 13 as an example. Wants to know which criteria is not used to determine whether a variance is exceptional. And we said it, or I must have said it. I must have said it so many times in class on Wednesday night that you got sick of it. And that was that just because a variance is favorable or unfavorable doesn't mean a hill of beans, because there could be lots of explanations for which way it should go or why it went the way it went, and they all may be good. They may be good things. So it's not an exceptional criteria to use in determining whether it's exceptional, and that's because we only use the term favorable or unfavorable as a relative weight, a relative term, to whether the actual was lower or higher than the standard. That's all it really means. And so, yeah, you probably would say or argue that for sure you're going to be interested in where you do have variances. But if you look at the other possible answers here, you got some much better answers in all cases. For example, A, the variance is based on a significant percentage of the standard cost. Well, that's a good criteria, because percentage-wise you can gain a lot from that. How much you wouldn't expect percentage differences to be high. The variance, so B could be just a low amount. That's why B is also not a good answer here. C, the variance is for a large dollar amount. That's the same idea as A, that it's significant. And D, the variance is for significant percentage of the flexible budget. And so again, they're all A, C, and D are all sort of like the same criteria of dollar amounts or percentages are really the key. Whether it's favorable or unfavorable is not really key. And so part of the argument you might make for this question of how to answer it is that it's really based on relative dollars or relative percentages, meaning the size. Just because it's favorable or unfavorable wouldn't be the criteria that you would use. So you might see the description, budget unfavorable variance. Oh, we got to look at that. Well, not necessarily. How much of it? What dollar-wise? What's the percentage? I think that's what the problem is teaching me. All right. Now that I learned what the lesson is to be learned, let's go to number 14. Shows you what I know. How much is the material price variance? That's what we're interested in now, the price of material. So here again, we're going to look at what was the actual price versus the standard price, and we're going to compare that to the actual amount, and this is where we talked about in class, not the amount used, but the amount purchased. So that's our formula, and now you got to find out from the problem what the numbers are. So let's see if we can figure out what we need to know to come up with this. All right, so they say that the company purchased 890 pounds, so that's what was actually purchased. They used 830, that's irrelevant for our purposes. They made 410 radon detectors, and they paid, and here's where we get involved with the 445. That's what we really need to know, because we're looking for price variance. All right, so 445, what they paid. How much did they buy? They bought 890. So now take $4. Let's get the calculator back on. $4.45 times the amount purchased, 890. So that's $3,960 is what they actually paid. Let's compare that to what they were supposed to pay. Maybe I have to give you some space to see. It was going to be $4.30 a pound. That's what they were supposed to pay. So let's see how that works out. $4.30 per pound for 890 pounds actually purchased gives us 3,827. And now again, you can begin to see that in terms of the poundage here, it's already looking unfavorable because of why? Because of the amount paid in total. The amount paid in total. And so I've actually solved the problem by the way I did the mathematics here. Normally you would have done it this way. You would have showed 445 minus 430 times the amount purchased, and that would have given you the same thing that this mathematical equation is going to give us. This gives us 133.50. This does the same thing. If you take if you take 15 cents, 15-cent differential, already in an unfavorable manner because the 445 is greater than the 430 budgeted amount. 15 cents times the 890, and you wind up with the same thing. So there's two ways to do the same thing. It's really the same algebra, same math, and the answer is A. Okay, how are we doing on time? Do I have time? I can't even see this board anymore. But let's erase the board and let's try the last one and see how we do. All right. This one's asking for material quantity variance. So now we're interested in how much was actually used for the production. We used for the production. All right, that was a little bit of a long pause I just had because of a phone call. So I hope I'm not starting off in the wrong problem. We're going to start off with chapter 312 now and do problems on that chapter. Wrong chapter. Okay, so let's see. I think we're on number 15. It looks like that to me. And let's see if we can knock this one off. That's what we got to look at. We're going to look for material quantity variance. So we're going to see how much we used compared to what we thought we would use. So first, let's take a look at what did we use. Well, the problem tells us we used 1,480 gallons. So we now have what we have is the actual amount. What was the predicted amount? That's a good question. I think the problem requires you to figure that out because it looks to me like it's buried in the problem. To produce 2,000 containers, they were expecting to use 96 ounces per container. I see that. Then 96 ounces and in order to do that, to produce 2,000 containers, they were going to buy, or they did buy 1,500 gallons, which is 192,000 ounces. So that helps us translate, I believe that helps us translate how many ounces are in a gallon, which I didn't look up. Turns out that number is 128. How did I get that? I took 192,000 ounces and divided by 1,500 gallons here and here. Think about that if you're not quite following it. But 128 ounces equals a gallon. All right, that's what I got out of that. I think we're going to need that information. And let's see what else we got here. We got a truck in the background, I think. So we'll let them go by. But let's see what else we have of interest. What we're trying to figure out now is we know how many gallons they used. What does the gallons means in terms of ounces that they use? I think that's also what we're going to need to figure out. Yes, we will, because we want to know per ounce. That's what we want to get to. So 1,480 gallons. Again, you may have a quicker way to do this, but I'm doing it my usual long, hard way. But it's at 128 ounces a gallon. So I'm going to multiply that out, and I'm going to get how many ounces we actually used. And I think I'm doing that because the price it's included in the problem is really per ounce. So we could have gone the other way and translate the ounce up to gallon, but I'm going to leave it in just translating everything to ounces. So 1,480 gallons of material that were used, because this is a quantity variance, is 189,000. So let's do this. Let's make a little bit of room here. Let's say 189 for 40. This is my actual. Now I want to try to figure out what the budgeted amount was for, meaning the standard amount. So now let's go figure out the standard amount, and then we'll be able to solve the problem. The standard amount was 96 ounces per container. So 96 times 1,480, which is what they actually produced, means that we would have thought that they would have, hold on a second, let me make sure I got it right, 96 per container, 1,480. Let me rephrase that. The actual number of containers is what we need to know. 1950, and they would have used 96 ounces for 1,950 containers. That is how many ounces that they were scheduled to use, 187,200. Let me restate that. What we're looking at is we know the amount of containers that they made. At the standard 96 ounces per container, we would have expected them to use 187,200 ounces. And now we see already that the actual was higher than the standard. So now we know we're going for an unfavorable result. Now we just have to quantify it in terms of dollars and cents. And so to do that, we're going to multiply the difference times the price per ounce, I believe. Let's see if that's what works out. So the differential between the 189,440, the 187,200 is 2240. 2240, that's 2,240 at 15 cents per ounce, and that's $336. And lo and behold, we got the right answer down there with C, unfavorable. All right, so to recap what I did, I'm going to do that quickly, so if you didn't follow it, you can follow it now. To recap what I did, I figured out that for 1,400, I figured out the following. To make 1,950 containers, sorry, to make 1,950 containers, they use this much in gallons. What does that mean in terms of ounces? So that's what I did. I translated 1,480 gallons into ounces, and the way to do that was to take the 1,480 gallons times 128 ounces. That's how many ounces are in a gallon. And I came up with, let's do the math again. Sorry for this. The math showed me that they actually used 189,440. That's what they actually used. The budgeted amount was 96 ounces per container. So that's the number of containers they made. Using that times the budgeted amount of 96 ounces per container, doing the math there, came to 187,200. The difference is 2240 times the standard rate per ounce, which was 15 cents, gives us our magic number of $28,888. No, wrong. 2,240 times 0.15 cents per ounce is $336. We know it's unfavorable. Answer C. Voila. And I think we're now done.